Hello. Hello and welcome to this video. In this video, we will further explore the functional programming aspect of JavaScript. Although JavaScript supplies several techniques to do with functional programming aspects, it is not really a true functional language. And we have already discussed that when we were discussing the tail call optimization of JavaScript and how both Chrome and Firefox do not implement tail-call optimization of recursive functions. You can have other functional programming aspects in JavaScript. Map is there, reduce is there, filter is there. Functions are first-class objects. You have call, apply, bind to support arbitrary techniques of functional programming. You can have even monads in JavaScript. So I do not remember if I discussed call, apply, and bind. I remember discussing call, apply, and bind in some context, but I'm not sure if in context of function I discussed them. So we will revisit that briefly. Suppose we have some function f and some object o, and we say f dot call o or f dot apply o. That basically means that you create a temporary property m of object o and assign a function to that, and then you call that property when the function is called, and then you delete that property. Now bind is different. Consider a function fy which sums this dot x plus y. Now we don't have this applied to this right now. It will be global this. Suppose an object o is there, x colon 1, and you bind f to o. That means the o's x will be received here in this dot x, and then you call g dot 2. So that becomes the y of the function f, and this will return 3. So that's how call, apply, and bind work. So I wanted to make that clear so that we can discuss that and there is no confusion in what is to come. So consider this function not f. So what it does is it takes the arguments, and this returns a function, takes the arguments and applies arguments to this object of f here, and it takes the result and then negates the result. So suppose we have a function even, and the function even checks whether a value is even or not. Again, it is an anonymous function. And then we have odd, which negates the result of even and tells us whether it is odd or not. And we pass 3 to even, which will be false, and then odd will be true, right? Because 5 will be false for even, odd will be true, and here everything is odd, so it will be true. So that is what we will see in the output. Now consider another function f. So what it does is that it returns an array which takes a map, not really takes a map, which if you invoke it with an array, it will map that array to that function. So our function increment in this case is whatever value you pass to increment, it will increase that by 1. So we call mapper on that increment and store the result as increment all, and we invoke it in the on the array 1 2 3, so it will become 2 3 4. Now consider a function which is which takes two functions f and g. Again, it returns a function with odds, and what we do this time is we call f dot call, and we do g dot apply with the odds. So here, suppose we have two functions, sum and square. Sum takes 2 arguments, okay, and square takes 1 argument. So here we, to the compose, we pass square and we pass sum. So square is f, so it will become square dot call this, and this will be sum dot apply, and then the arguments will be passed here. So it will become 2 plus 3 and then square 25. Now we have some interesting functions with which you can do a lot of stuff. One is called partial left. So what it does is that it takes outer args and then returns a function with inner args. You build the args list with outer args and inner args, and you apply the function on this and args. So partial right is the quite opposite of that. Here outer args is here, and we have inner args to the function. Okay, and then we have the opposite order here. Args are now inner args is first and outer args is later, and then we apply the function. And then we have partial function which will remove the undefined elements in the args and replace them with inner args. So the function here which we return takes inner args and args becomes outer args, and then we iterate over this args, that is outer args, and whatever is undefined we substitute that with inner args. And finally what we do is that we uh, push the remainder of inner args to args, and then we apply all on that. Now suppose we have a function x which takes three arguments, x plus y plus z, and we have x times y minus z, that is the function. Now if you take this function partial left, then it will be 2 times 3 minus 4, okay, because it will take the left args. And if you take right side, then it will be 3 times 4 minus 2. And if you pass an undefined value, then it will be minus 6 here this time, okay. Now there can be far more interesting problems on this. Consider sum on this. Partial left, you apply sum with value 1, and partial right on master.pow comma 1 by 3, so it is a cube root. So increase 26 by 1, it will become 27, and then cube root 10, that is another example. So cube root here will be 3, and this will be 2 point something. There can be even more interesting applications. Partial left, you can call compose by supplying a function, and even function is same, odd is same. Is number, you take an AND and then you negate that, and then you can test whether 3 is odd or not, and is number, the test is whether 2 is a number or not. So these are some interesting problems, and if you remember our previous video where we did calculate the standard deviation and mean, you can convert that entire program using partial left and partial right. So now we look at another programming technique called memoization. So what memoization is, I'll give you an example. So suppose you want to compute Fibonacci series. That is the best example I can think of for memoization. Suppose you want to generate a series of Fibonacci numbers. Say you are asked to generate the value of 20th Fibonacci number. So what will happen is, if you do the typical recursion, what will happen is you compute F19, and in order to compute F19, you have to compute F18. So the typical recursion code which we people like is B is equal to fib B minus 1 plus fib fib B minus 2. This is the typical way people write recursion when they are beginning programming. Now this calculation of B minus 1 will involve B minus 2, and B minus 2 will involve B minus 3 and B minus 4, and this will also involve B minus 3. So twice you are computing B minus 3 for this B minus 1, and then you will compute B minus 4 twice and B minus 5 twice, and so on. And again here you will compute B minus 3 once, and that would mean B minus 4 once, or rather twice, B minus 4 twice, and then B minus 5 twice, and so on. So see, it's a very problematic way of doing the calculation. So what we do is, instead of doing that, you can cache the values already computed. So what you do is you declare a new map. We have not discussed it. The hash map key value pairs are stored in this, and we have a function, and we take args.length and we add to that, okay, plus. So length plus is the key. Now if cache has the key, you get the key, else what you do is, on the result you apply the function on the arguments, okay, and then you take the result and set against the key, and you have the result, okay. So we'll see how this works. All right. So we have the classic GCD algorithm of Euclid. We take two arguments A and B, and we ensure that A is greater than B by swapping here. And while B is not less than equal to 0, we do the calculation of GCD. Now what this will do is that it will store the previous values. Okay. So if you do memorization of 85 and 187, it will store that. And similarly for factorial, if you do this, it will store, if you calculate factorial 5, it will store the value of 432. So if you calculate factorial 10 next time, then it won't calculate factorial 5, 432, and 1, because those are already stored. So what will happen is, in those cases, whenever it will see that cache has the key, then it won't do the calculation. It won't do the f dot apply, and it will simply get the key from the cache. Okay. Now that is one thing. Now you have to be careful about the caching. Okay. What can happen is, in certain cases, if the input is too large, okay, your cache might fill a lot of RAM. So you have to be careful about what you're going to put into the cache. You don't want to consume so much RAM that there is no space left to the RAM. Also, in the second calculation, you see that we recurse on the memoid function, not on the original function itself. So that care also you have to take. So these are the things which you can do with JavaScript and functional programming in JavaScript. You can employ these techniques everywhere in the program. Just know that certain places it can become quite messy. For example, let me give an example. So let's look at this partial left, partial right, and partial functions. Now, if you apply this partial on f and pass these arguments, then actually doing the evaluation of code in your head becomes problematic. You have to go through this entire function and you have to execute this code. Okay. Now, this is kind of taxing. The cognitive load increases on the human being. You know, there is a very good article. I'll show you. Okay. Let me show you. This is written by Mark Trevor, if I remember, that bipolar list programmer. Okay. If you search this, you'll come to this article. It is definitely, you should read it. Mark Trevor has written it, the bipolar list programmer. In this particular post, he describes why Lisp, even though it is such a nice and powerful language, is not successful commercially. Not a lot of people do Lisp programming, and there is reason behind why people don't do Lisp programming. Although the article is quite accurate in its description, I want to raise another point about functional programming. The problem with functional programming is that you have functions and functions and functions, and there is deep nesting of that. And execution does not work. Human mind does not think in that terms. That is one of the reasons why you will struggle with the recursion. A simple concept like recursion can topple your thinking if it is mutual recursion of 4, 5, 6 functions meshed with this kind of partial function. So personally, it is my opinion that the reason for failure of functional languages is that it does not fit into human brain. You can far easily understand imperative code or object-oriented code because the code is quite simple. It follows in steps one by one. But in the function call, when a function call happens, it's a context switch. You have to carry the arguments and you have to carry whether it's by value, by reference, and whatnot. And then you have to apply that function, and then you go on to another function, and then you come back. So there is stack winding and unwinding which happens. So for me personally, it is very difficult to understand functional programming code. It is very hard to really reason about that what is going on. For example, if I see this kind of code in real life, this partial code, I'm not going to keep that. I'm going to replace it with imperative code because it does not make sense to me. This is fairly simple and trivial. So yes, I can manage it to understand it. But if it is complicated, then I will probably throw it. But again, that is my personal opinion. Lots of people write functional programming code, and possibly I have not spent a lot of time doing functional programming, so that is probably one of the reasons my mind is not tuned to that. Maybe if you get used to functional programming and you love it, then yeah, well and good for you. But in general, the failure reason is that is one of the reasons. The second reason for failure of Lisp and Scheme is the parenthesis thing. Most programmers do not pass the initiation test of Scheme and Lisp. Then you have got prefix math. Okay, so there are lots of reasons why Lisp and Scheme did not become successful. So we can have an argument over that if you may ever meet in person. But my idea is that keep the code simple. And personally, I like C most, and nowadays I like Rust because there's very little complexity in understanding the code bases of C and Rust. Rust makes it quite easy to reason about things which you skip in C. And once you see the value in Rust code, you are never going to go to another language. There is a reason why it is the most loved language in all of programming. Although macros are a bit of pain, but yeah, eh, you don't get everything. All right, macros are useful, and you can use macros to write DSL, but reading macros is pain. It is painful. Again, it is about getting used to the syntax. So with this, I will end this video here. I hope that you have found this video useful and informative. What you think, let me know in comments. And I would like to show you my website. So this is my website. You can download books from here. And specifically, if you want to ask questions, you click on the X link, come to my website, vandika.ashtok.org. It is a question answer website. You can come and ask questions. You can make use of the tag JavaScript. Yeah, JavaScript is here. And if I know the answer, I'll be most happy to answer your questions. So with this, I'll take my leave, and we'll meet again on the fourth day with another video on JavaScript. And we will move on to probably classes or arrays. Arrays we have covered, right? We'll probably move on to classes. Okay, let me remember. I don't think it will be other arrays or classes. My memory does not serve me. So we will start a new topic in the next video. So thanks a lot for watching the video, and I'll see you in the next one. Enjoy.